at arcs and central angles. And the first thing we have to do is define a central angle. A central angle is an angle whose vertex is at the center of the circle. So this angle shown right here, angle ACB or BCA, that's a central angle. All of these are central angles. Pretty much every angle on this page that you see is a central angle because they all have a vertex right at the center of the circle. We're going to talk later about angles that have their vertex outside the circle or inside the circle but not at the center, or angles that have their vertex on the circle itself, on like the edge. So it's very significant when you're talking about circles to look at where the vertex is. So this is specifically when it's at the center, we call it a central angle. Now an arc is a piece of a circle. If I take a circle and I basically trace a piece of it, like if you made your circle out of string, a piece of it you could cut and pick up. Or you could think of it like a track, and it's a track for ants. And I say, I'm going to put my ant down here, A-N-T, and he has to walk until he gets here. Then he has walked through an arc. An arc is just a chunk of the circle. It can be small, it can be large. You could kind of think of the whole circle as one arc that goes all the way around. But that's basically what an arc is. So a minor arc is a part of the circle that measures less than 180 degrees. When we name a minor arc, and this is very important, so I'm going to add it in right here, we name it by 2 endpoints. So that's 2 points that are on the circle. So right here, that's minor arc AB. And notice it has a little arc symbol over the top, a little curve over the top. That's part of how we name an arc. Okay, let me make that just a little bit bigger. So this is a minor arc AB. Anytime you name an arc with just 2 endpoints, it means a minor arc. Okay, a major arc is part of the circle measuring between 180 and 360. Okay, now it's named by the 2 endpoints and also another point on the arc, which basically means it has 3 letters. You cannot name a major arc like right here. Let me make that a little bigger. A, D, B, the arc over it. You can't name a major arc without using 3 letters. You have to use 3 letters to name a major arc. Because here's what you're doing. Okay, I like to think of it as, you know, let's see. Isabel is over at Natalie's house. Here's Isabel. She's at Natalie's house right now. And her mom calls her from home and says, when are you coming home? And she says, oh, I'm sorry. I forgot I was supposed to be home by now. I'm going to leave right now and come home. Okay. Well, then if this is like the next street over, her mom is expecting her to be pretty quick because she's expecting her to take the shortest distance from Natalie's house to home. Okay. That's a minor arc. A major arc is when she says instead, oh, wait, I forgot I left my sweatshirt over at London, so I'm going to have to go by London's house on the way. And so therefore, her mom knows she has to go the long way, out of her way, to go past London's house to get home. That's a major arc. Okay? So when we name a major arc, you have to point out with that middle letter, I'm going out of the way. I have to go past this point to get there. So that orange arc would be arc ILH, or you could call it HLI. It doesn't matter which order. But if you talk about arc IH, it automatically, every single time, 2 letters means the shortest distance between these 2. So you're going the shortest way around the circle. Okay? Now, the only time that could be a little bit confusing is with the thing that's not greater than 180 or less than 180. It's a semicircle. It is 180. Semicircle is an arc with endpoints formed by a half circle, I guess is what they're looking for here. But I'm going to go ahead and say 180 degrees. Okay. Notice it's named by endpoints and another point on the arc. So we use 3 letters to name that also. Technically, you could use 2 letters for a semicircle. It kind of depends on your context. If I'm trying to identify which semicircle I'm talking about, then I really need to mention that extra letter to say, oh, I want the one that goes past this point, not the one that goes the other way. If I'm just trying to find out how much it measures, it doesn't matter. It measures 180 either way. If you go halfway around the circle, it doesn't really matter which way you went. You're still halfway around the circle. Okay? So 3 letters could be a semicircle. It's usually a major arc. There's no way to name a major arc without using 3 letters. And if I only use 2 letters, that's automatically a minor arc. That's automatically less than 180. It's the quickest distance from here to here. That's Isabel saying, I'm coming straight home. Okay, so her mom expects her to take the shortest path, not to go the long way around. If she says, I'm coming straight home, and then she has to go to London's house, and London lives 2 miles away, her mom's going to wonder what took her so long instead, right? So that's why the major arc has that extra letter to say, I'm going the opposite way around the circle. I'm going the long way around. All right, so looking at these 1, 2, 3, this whole bold thing, it can be a little hard to see. It says, name the arc shown in bold. I'm going to highlight it too. So here's the one that's bold here. Here's the one that's bold here. And here's the one that's bold here. Okay, so if I'm going to name the arc that is shown in bold, this one is it minor or major? Minor. That's a pretty small arc. So I could just use the 2 letters. It doesn't matter if I say A, B, or B, A. Either one is fine. I could say this, or I could say this. Both of those are fine. What kind of arc is it on number 2? That's a major arc. So that's more than 180. So I have to use an extra letter to point out I'm not going the shortest way. I have to pass D on my way. Now, one thing that sometimes people get confused about is if there were a whole bunch of letters, like let's say it looked like this. But there was also this. You don't need to name everything you're going to pass. You just need to name one thing that points out, oh, you're going the long way around. Okay, just like Isabel saying, oh, I have to stop by London's. She's not going to mention everybody else who lives in the same direction as London. She doesn't have to. She's not going to mention, oh, I'm passing Quick Trip, and then I'm passing Walgreens, and then I'm passing, et cetera, et cetera, et cetera. You don't have to name all the points. You just name one point that says, oh, you're not going the short way, you're going the long way. So if I named this arc a CB or a DB or a EB, all of those are fine. All of those are talking about the same arc. They're saying you're going from A to B or B to A, same thing, but you're going the long way. You're going the way that passes this side of the circle. So you don't ever use more than 3 letters. Even if you see a whole bunch of extra points over there, you only pick one of them that says, oh, you're going the long way then. Okay, got it. All right, so this would be either ADB or you could call it BDA. The first and last letters still need to be the ends of the arc. It's just you're squeezing an extra one in there that says, oh, you're passing this guy on the way. Okay, and here we just said we're going to use 3 letters for a semicircle. So for this arc up here, I would say PSQ or QSP to point out that I'm going the direction that passes S on the way. So PSQ or QSP. I'm going to put that or, because either one of these is fine in each case. Questions so far? Okay, measuring arcs. The measure of an arc is not the same as the length of an arc. Okay, I mentioned when we're first talking about arcs This is like an ant walking from here to here. I have a little ant who's walking around the circle. Ant as in an insect. Let's see, they have 6 legs, right? There we go. If I ask you how far the ant walked, that would be something like centimeters or inches or something like that. That would be like taking a string that goes from here to here, tracing my way around the circle on a string, and then picking up the string and straightening it out and measuring it. That's arc length. That's not what we're doing right now. We're talking about degrees. So the measure of an arc is in degrees. It's how much of the whole circle does this arc take up. What's a whole circle in degrees? 360. Good. 180 times 2 is 360 degrees. Okay, so we're basically saying how many out of those 360 degrees does this arc take up? How much around the circle does it take up? So the measure of an entire circle is 360 degrees. Measure of a semicircle is 180 degrees. What would that mean a quarter of a circle would be? 90 degrees. A quarter of a circle would be 90 degrees. Okay, so the measure of a minor arc is the measure of its central angle. I'm going to use a little m here because we do that for measure. The measure of arc RS, that's this one here, is the same as the measure of the central angle that goes with that arc. So that means it's the same as the measure of of angle RPS, or I could have called it SPR. Let's zoom in a little bit. Okay, the measure of the major arc, it's still, you can still think of it as going with the central angle. Basically, the arc measure is the central angle measure for that particular arc. But usually for major arcs, we end up subtracting. It's the difference between 360 and the measure of the related minor arc. In other words, the measure of arc RTS, which is the long way around, would be 360 minus RS. Okay, so in this particular case, the measure of angle RPS is what degrees? 45. So that means that's the measure of arc RS. So I would say the arc measure for arc RS, this part right here. Sorry, I've got a shadow. I'm going to color it in a little bit. Arc RS has an arc measure of 45 degrees. It's different from arc length, but we actually tend to do arc measure a little bit more often. And then the measure of arc RTS, which is going all the way around the other way, is 360 minus 45 degrees. What would that be? Good, 315 degrees. All right, the next one is kind of a, it's almost like angle addition. It's kind of intuitive. If I needed to put 2 arcs together, I would add them. That's what it's basically saying. The measure of an arc formed by 2 adjacent arcs next to each other is the sum of the measures of the 2 arcs. Adjacent arcs are arcs that share a common endpoint. So in other words, the measure of arc ABC is the measure of arc AB plus the measure of arc BC. That's all they're saying. Okay, congruent arcs, right below here, we've got congruent circles. We already know congruent circles have the same radius. But congruent arcs, there's a little bit of extra here. I can't say 2 arcs are congruent just because they're both 30 degrees. It says 2 arcs with the same measure, and they are arcs of either the same circle or congruent circles. So to say that 2 arcs are congruent, I really have to point out they have to be the same degrees, but on the same size circle. So like the radius has to be the same for that circle. Okay. Decide if arc AB is congruent to arc CD. Explain. So here, this would be a no, because the circles are not congruent. I know they're not congruent because the radii are not the same. Radii is the plural of radius. So one of them has a radius of 12. One of them has a radius of 10. So the circles aren't the same size. So I can't say that the arcs are congruent if the circles aren't the same size. AB is congruent to CD. Well, this one I actually have to figure out. Okay, I'm going to draw it bigger so that I can write on it. One thing I mentioned earlier that we're usually allowed to assume with pictures of circles is we're allowed to assume that if it looks like a chord goes through the center and is straight, we're usually allowed to assume it's a what? What kind of chord goes through the center? A diameter, good. Okay, so in other words, on this particular one, it's safe to assume that AD is a diameter. Okay, now I was told that this angle is 63 degrees. That's a central angle, and that means that this arc measures 63 degrees because the arc measure and the central angle measure are always the same. I was also told that this arc is 54 degrees. Excuse me. So if I'm assuming this is a diameter, then this means that this whole thing is 180. We use that a lot. Anytime you see a diameter, we use that one side of it is 180. Either side. Either side of that has to all add up to 180. Okay, so I can figure out what this arc right here is by saying the whole orange arc there that I highlighted has to add up to 180 because it's on one side of a diameter. So I'm going to subtract 180 and get the glare off of it, minus 63 and minus 54. And I get 63. And that's what I was asked, is if this arc is congruent to this arc. So yes, they are. They're on the same circle, which means the radii have to be the same. The radius is the same. Remember, they have to be on the same circle or on congruent circles. So I'm going to say yes. And they're both 63 degrees. What kind of angle pair is pictured in this last one? Good, vertical angles. Vertical angles keep coming up. Vertical angles happen everywhere. They happen in all kinds of shapes, including circles. Anytime you have two lines crossed, that makes vertical angles. So that means this central angle over here is congruent to this central angle over here. So that means whatever this arc is, that arc is. So yes, they are congruent by vertical angles. It's the central angles here that are my vertical angles. Any questions on the front of the page before we move on to the back? All righty. Okay, in circle O, segments MQ and NR are diameters. Okay, they're just saying, yes, this really is straight. These two are straight lines, so this is a diameter, this is a diameter. Remember, that means everything on one side of it is 180. Find the indicated measure. Now, this is a perfect example of a problem that I know I've talked to you before about problems like this, and that is you've got a lot of information on one picture and all your answers are going to come from that one picture. I would just do everything I could to figure out the picture itself first and then go look at what they want. In other words, I'm going to ignore this part and just look over here and see what else I can figure out. Okay, so the first thing that occurs to me here is that those two diameters form vertical angles. Is that what you were going to say? Okay, so this is also 60. Okay. And I could go ahead and say that means this arc is 60 or that means this arc is 60, but I'm going to stick with the angles in the middle for a second here. Because the next thing that I notice is, since I have a diameter, I've got several cases, several opportunities to say, oh, all this has to add up to 180. Like I could say everything below here has to add up to 180. Or I could say everything on one side of this has to add up to 180 because it's a diameter. So let's go with this one. If all those three angles, 60, 80, and the one I don't know, if they all have to add up to 180, then I'm going to subtract 60 and 80 from 180, and I can find this angle that's missing down here. Okay, so 180 minus 80 is 100. Minus 60 is what? 40. So this angle right here has to be 40. Okay, and then I could do the same thing here. This is a diameter, so everything on one side of it has to be 180. So I only have two angles on one side of it. Those are a linear pair. So 180 minus 60 is 120. Okay, and now all the arcs go with the central angles. They're the same as their central angle. And after I figure all that out, that's when I would go back over here and start trying to figure out what do they want. So see if you can fill in all of these from what we just found on that picture. I'll give you a couple seconds to do that. Sorry. Okay, I'm going to start filling them in, but you don't have to stop. Just look up when you're ready. Whenever you're ready, check your answers against mine. Yeah. Let me know if there are ones you want me to go over. Yes, ma'am. Okay, not yet. Any questions about this one you want me to go over? Okay, let's go ahead and see if we can get through these last two. Find the value of x. If that's x, this is x because of vertical angles, right? So these three together are on one side of a diameter, which means they have to add up to what? 180. So I'm going to subtract 80 from 180. That gives me 100. Then I subtract 67. That gives me 33 degrees. Okay. The next one here, I'm going to have to kind of set up an equation. I've got 3x over here, and this congruence marking means this arc is the same as this arc. So that's also 3x. And again, I have a diameter, so everything above that diameter has to add up to 180. This one is 90 degrees. That's what a right angle symbol looks like, right? So that tells me this is 90 degrees. So altogether, what I have up here is I have 3x plus 90 plus 3x equals 180. And then I can solve that to find the value of x. While you guys are working on that, what was your question about the homework as well?
So like number 1 and 2, look how the diameter. How are you supposed to solve for like to find j and
You would subtract from 360.
Oh,
Yeah. Okay, that's all right. Let me finish off this problem and then I'll make sure you guys see what we were just talking about. So that's what I get for number 9. Questions on that one? Her question was, if I don't have a diameter, how can I figure out what this whole arc is? Well, the two things we mainly use are diameters, break the circle into 180, and the whole circle is 360, remember still. So if I know that this part is 127, 360 minus 127 will give me the other arc. Okay, they have to add up to 360 together. So this is your homework. You really need to do all of it. Okay, sorry, I can't really just give you the odds or something because all of these are important problems. And some of them are very different. Okay, I'm going to change my mind on that. You can go ahead and just do the odds. Do the odds. If you want some extra practice, you could do more than the odds because I may assign them later, but for right now, you can just do the odds. Okay, so that is on Google Classroom. For those of you at home, you guys here, you can go. Question? Hang on one second.